account for more than 40% of energy consumption and are the largest CO2 producers in many world regions. The Greener Buildings project, supported by the European Union, investigates how buildings can dynamically adapt their operations according to the actual use of the building. This is achieved by constantly measuring user activity with basic, widely available sensors and controlling building resources like heating, lighting, and office appliances.
The main point of Greener Buildings is, can we save energy by using activities that are automatically recognized and then used for control purposes.
But the other aspect is really understanding the user experience. So let's say our expertise is understanding the user experience and also trying to validate the user experience in a kind of more scientific way.
Our studies typically went through installations, so we installed this technology, including the framework that we developed in the project, into different office environments. We call this living labs. That means that occupants who normally live in the office, who normally work in this office, use the technology that has been developed in the project.
In the office space we have the ultrasound sensors. They just measure the distance of objects in front of them. Then we use the passive infrared sensors, which are commonly known as motion sensors. We use that combination to stabilize the system, the signal of whether or not the person is using the computer or is within the desk area, and whether or not they're using the computer or they're working at the desk. And based on that, we take action like turning off the screen and then dimming the lights.
We can save about 50% of energy in computer screens by switching them off at the moment that people are not using the screen. We can save about 20 to 30% of overhead lighting by dimming lights, for example, when computers are used, and to brighten the lights when the people use not the computer but do some desk work, which involves paper, so where there is more light needed on the desk.
Sensors inside the building detect user behavior and working conditions. In addition, outside sensors provide information on weather conditions. Changes in the environment and use of the building are constantly processed and compared to historic data. The Living Lab adapts light and climate control, but also office appliances in real time to the current situation. The Greener Buildings system is a novel energy-aware building management system. The system recognizes and interprets occupant activities together with other building context information. User control operations are used as system feedback. The architecture consists of 3 layers. The lowest layer is the physical layer. In this layer, the building's state is measured and the automation is controlled using widely distributed sensors and actuators. User activity and context is recognized, abstracted, and managed in the ubiquitous system layer. This layer also stores historical data to revise operations over time. In the composition layer, user rules are applied to compose the most energy-efficient control operations that are then executed in the building. This architecture makes the building energy-aware while accommodating user preferences.
We have a lot of data in this project. That means, for example, all the sensors are reading constantly some various temperature. Or we have sensors that measure the distance between the sensor and an object. They evaluate every twice per second. So if you sum this up, we will end up with a lot of data. And this is, of course, challenging to process and deal with this amount of observations.
The system supports many different spaces within a building, such as open offices, small offices, and meeting rooms. In the latter case, sensor data patterns are recognized to identify different usage scenarios and control meeting rooms in the most energy-efficient way. This could even be combined with the planning and scheduling system of the building to automatically anticipate the planned use of a meeting room to prepare the climate beforehand.
The meeting room is a challenging scenario because people are coming in and out and they don't have a fixed place, so you have to use techniques that are of a broader scope. So we split the meeting room in 3 areas. It actually allows us to control different light levels depending on the number of people and depending on what the activity is. If it's presentation, then you would want the light over the front of the room where the beamer is projecting to be off. When there is no presentation and you actually want some light from the outside, you always want to have as much natural light as you can. And we have all the thermal conditions, so we have CO2, humidity and temperature inside as well as outside. As you can see, there are many conditions that the system has to be optimizing all the time, and you only have to write the rules of exactly what you want to ensure comfort, and then the system does the whole, solves the entire optimization procedure to get to the point that is the cheapest option.
Measuring energy consumption, we can quantify that, but measuring comfort, for example, there are many factors that might be influencing it, and you don't know for sure whether it's related to your solution or if it's related to whether people have a bad day that day. And of course, we at least try to eliminate some of these fluctuating conditions as much as possible. When we see, for example, that people feel more in the loop with technology, people will use less energy and will feel more satisfied when they feel in control. So the system is constantly trying to optimize the energy consumption according to the different activities that the user is undertaking, but with the option they can always override it. Give people control and they will tend to lower it below those regulatory requirements.
The fact that you really have to go and dig and understand the limitations of the current sensor modalities, the limitations of the current technologies, and the fact that you have to come up with new algorithms and new techniques to be able to reuse all this information, for me is, I think, one of the most interesting things.
This is novel, this hasn't been investigated before. How to automatically adjust the environment in order to achieve an energy efficient setting of the room, of the building. And if you scale this up for a whole building or for many buildings, then of course there is a large amount of energy that can be saved.
It's really green research, right? Because there's a lot of energy wasted in office buildings.
Having this platform, being able to demonstrate it and also play with it and offer it to others in the end of the project so that they can also develop applications on it. In that regard, I do think it's a success, yeah.
It's a successful project also because we have a number of results that are now being used by companies who develop further products out of the research that has been done.